Welcome back everyone. In previous video we discussed the definition of the derivatives, and in this video I'm going to focus on power. Let's start with the definition of the power rule. As you see in here, we have basically the variable of x to the power of n, and the power rule says whenever we have a variable to the power of a parameter like n, in order to use the power rule, we just need to bring the power at the upfront of the variable, as you see in here, and then reduce the power by 1. So in here we have x to the power of n. So the answer of this derivative is going to be n, which is the power, and then times x to the power of n minus 1, and actually we reduce the power by 1. Let's look at one example. In here we have f of x equals to x to the power of 5 plus 5x squared minus 4x minus 1. And in order to find the derivative of this function, we need to find the derivative of each term one by one. So let's look at the first term, which is x to the power of 5. In order to find the derivative of this term, we have to use the power rule, and easily we can say, okay, the derivative of this is going to be the power at the upfront of the variable times x to the power of 4, which is basically 5 minus 1. Let's look at the second term, which is 5 times x squared, and in order to find the derivative of this term, again we have to use the power rule. And based on the power rule, we can say, okay, we have basically the constant 5. We have the constant 5, and if we bring this 2 to the upfront, it's going to be multiplied by this 5, so it's going to be 10, and if we reduce the power of 2 by 1, it's going to be 1, so the final answer for this term is going to be 10 times x. Let's look at the third term, which is minus 4x. So for minus 4x, what we have in here, this x, which has the power of 1 actually, and if we bring this power to the upfront, it's going to be multiplied by minus 4, and if we reduce the power of 1 by 1, it's going to be 0x to the power of 0 is actually 1, so the answer at the end is going to be minus 4. And the last term, which is minus 1, and it is a constant number, and we know the derivative of a constant, any constant, is 0, so the derivative of basically minus 1 in here is going to be 0. Therefore, the final answer for this problem is going to be the first term, which is 5x4 plus 10x minus 4. So we easily applied the power rule in order to find the derivative of this polynomial. Let's look at the second example. This time we have a function with rational power. Similarly, we can implement the power rule in here. So it's going to be x to the power of 1 over 5, and in order to use the power rule, it's the same as the problem that we solved. So the power is going to be at the upfront of this function, so we bring this power in here, so it's going to be 1 over 5, and for the power we just need to reduce it by 1, so it's going to be 1 over 5 minus 1, so the answer is 1 over 5 times x to the power of minus 4 over 5. So we just reduce the power by 1, and we just brought the power at the upfront of the variable. The other case that we can look is basically negative integer power. So as you see in here, we have the function of f of x equals to x to the power of minus 2, and in order to solve this problem and in order to find the derivative of this function, again we need to use the power rule. Similar to the previous problems, we have to bring basically this power to the upfront of the variable, so to the left side. So the answer is going to be minus 2, as you see in here, times x, and the power is going to be reduced by 1, so the answer is going to be minus 3. So the answer of the derivative of this function is minus 2 times x to the power of minus 3. So what we did, we just applied the power rule in 3 different functions. The first one was actually a polynomial with positive integer power, and also it contains a constant number. As you see, the final answer was 5x to the power of 4 plus 10x minus 4, and we just applied this rule in here. And then we looked at a function with a rational power, and we basically applied the same rule. We brought the power at the upfront of the x to the left side, and we reduced the power by 1. And then we looked at a function with a negative integer power. We did the same, used the power rule, and we just actually brought this minus 2 at the upfront, and then what we had was x, and then we reduced the power by 1, and the answer was converted into the form of minus 2 times x to the power of minus 3. So anytime for using the power rule, remember this basic concept. You need to bring the power to the left side of the variable and then reduce the power by 1.